So looking at plane motion with respect to moving. Oh, and also homework 7 will be posted today, so keep an eye out for that. Rotating frame. Also, in your lecture notes, if you open the notes for week 11, class 1, the first page is the geometrical solution with the video for which I'll be posting. All right, so you have those, the written out solution from me as well. All right.
That was week 11.
That's week 11, class 1. Yeah. All right, so what we have in this case is we've got our fixed frame of reference. We're going to change things up now. We're going to say that the fixed frame of reference is capital X, capital Y, and capital Z. All right, and then we've got our moving frame of reference. Small x, small y, and small z. All right, let's say this is the point O. We're looking at some point B on a rigid body. All right, but what we're told is that this frame of reference, the small one, is actually rotating. All right, and what we're going to do is we're going to give it a angular velocity, and we're going to give it an angular acceleration. And we're referring to those as capital omega and capital omega dot. All right, and then we do all of the usual things, right? So you have, let's see, that is your position vector for the origin there. That is your position vector with respect to your fixed frame. And then here you've got your position vector with respect to this moving frame. All right, let's get the definitions out of the way. So we have capital X. Let's make it color coordinated. Capital X, capital Y, and capital Z frame is fixed. And then we have little x, little y, and little z. And that frame is translating and rotating. And this rotation is happening, rotating with an angular velocity vector, omega, and an angular acceleration vector, omega. It's basically the same thing as think about omega, think about alpha, right? It's basically the same expression. Not the same expression, the same terms. All right, and here we know that they're about the k hat because we're looking at planar kinematics, right? So this omega we can write as omega k hat, right? And this we can write as alpha k hat. All right, favorite thing, start off with the position vectors, right? We have that R of B relative to O is equal to RB minus RO. Right, so you take the differentiation, right? You'll see that d RBO over dt is just going to equal RB dot minus RO dot. Right, so that's just equal to VB minus VO. All right, now what we also want to do is wanted to find the unit vectors. So we define unit vectors in both our coordinate frame, right? So in the moving frame, you get small I hat, small j hat, and small k hat, right? And in the fixed frame, you get capital I hat, capital J hat, and capital K hat. The important thing to note here is that these unit vectors do not stay constant with time. Whereas capital ones do, because it's a fixed frame. So question to you guys is, why do small I hat, small j hat, and small k hat not stay constant with time?
Is it because of acceleration and it's not constant, and acceleration isn't constant?
Simply because of this rotation. The fact that this rotation is happening, this one is going to be constant because k hat position is never going to change, but I hat and j hat, they're rotating, right? So, rotation about this, right? So if you look at I hat and j hat, k coming out, because of the rotation, I hat and j hat are constantly changing directions, right? So I hat and j hat are not constant because they're simply changing directions with respect to time because the frame is rotating. Is that clear, guys?
Yeah.
Do you typically want to set up your rotating or your moving frame of reference in whatever axis of rotation? Make one of your axes that.
We're always looking at planar motion. Your axis of rotation is always coming out of the page.
Okay.
That is our pay grade. You're going to get more complex pay grade when you guys start working with Dr. Garashi with machines and mechanisms, right? That's when you start looking at 3D stuff. All right, so what I can say for R of B relative to O, right? I'm going to basically do some quantifications, right? So this quantification there and that, the magnitude there. So I'm just going to say that's equal to, in the moving frame of reference, x small I hat plus y small j hat. And this is in the moving frame. Then when I take the differentiation for this, because I have to take the differentiation for on this expression here, what I can say is that the derivative of RB relative to O with dt, now I have to use chain rule, but the thing is that my di over dt terms are not going to be 0 because the frame is rotating. Right, so this is going to be dx over dt times I hat plus x times di over dt plus dy over dt j hat plus y times dj over dt. All right. The summation of this term And that term is okay. That is just the velocity of B relative to O, because it's just the rate of change, that and that with respect to that point. All right. The things that are not known is what is that term and what is that term. All right, so let's call this expression number 1. In order to find these terms, you have to look at your moving frame of reference relative to your fixed frame of reference. Now I have my fixed frame of reference. And what is the magnitude of these unit vectors?
One.
1, right? Unit vectors. I hat and j hat, right? So what that means is that I can literally draw my unit vector sector circle out, right? And what I can do is I can define my I hat and j hat like that, right? We can define this angle theta. Right? What I can say is that di over dt is just equal to di over d theta times d theta over dt. Right? Now
So
here,
kind of
guys.
partial derivative.
No. This is just chain rule, I think. Product rule. Right? You just introduce this numerator and denominator there. What is this term, guys?
Angular acceleration.
Velocity, right?
Velo-
This is just
Oh, that
equal
would be
to
second derivative. Yeah.
your angular velocity.
Are we using uppercase omega for that now?
Sorry?
So is that uppercase omega?
Yeah, uppercase omega. So uppercase omega and uppercase omega dot, right? Same thing as lowercase omega and lowercase alpha. Exposing you guys to everything that you might come in terms, might be exposed to, all right? All right, I think good point to stop. We're right at time. We'll continue on Thursday.
See you Thursday.
Good. Thank you.
Thanks, guys.